So the second half of 12.2 is about arithmetic series, basically the sums that we talked about. We're going to be talking about the partial sums of an arithmetic sequence. So partial sums. Sequence. Now, of course, when you say a partial sum of a sequence, that's basically calling it a series. So, aka an arithmetic series. Squeeze that in there. Now, to save you the trouble of talking about where it came from, because I know that has not gone well in the past, I'll just go ahead and plop the formulas down if you are truly interested in where these formulas come from. It's a pretty neat story and pretty neat derivation. It doesn't take a long time, but I don't want to confuse everyone with it, so I'll just go ahead and go straight to the formula. But if you are interested, just ask me, email me, and I'll gladly go over it with you all. So, let's write down the statement. The nth partial sum of an arithmetic sequence, that is to say, the sum of the first n terms of an arithmetic sequence, may be calculated by, is it with, calculated with, I think it's with, calculated with, and there's actually two variations to this formula. So S sub n is equal to n over 2 times the first number plus the last number, or S sub n is equal to n over 2 times 2 times the first number plus n minus 1 d. And the reason why there's two variations is because, it depends on what information you are given. So where a sub 1 equals the first term, a sub n equals the last term, n equals the number of terms, and of course d is the common difference. So that is how you go about in finding the partial sum of an arithmetic sequence. So it's just just an application. If you know these formulas, it's just an application of the formula. So looking for the pieces. So you're looking for the first term, the last term, and the number of terms, or you're looking for the number of terms, the first term, and the common difference. So that's what you're looking for, and you use whatever formula suits your needs. For example, suppose I asked you to find the sum of the first 50 odd numbers. Now this seems like an odd or weird question, because, how am I supposed to do that? I think if you write it down, you can easily visualize it. So what are the sum of the first 50 odd numbers? Actually, let's revise the question. Sum of the first 50 odd positive numbers. So if we were to write that down, what it's basically asking you is to do 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus dot 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 dot, go on going forever. But we want to do this, we want to have 50 numbers. So hopefully everyone can agree that this is actually an arithmetic series. Why is it arithmetic? Because as you progress, you're always adding the same amount. So I hope this is just a straightforward analysis, just no calculation. You're just looking at it. we can see that this is arithmetic with, well, we can obviously tell the first term is 1. The number of terms, they flat out told you was 50 numbers, 50 odd numbers, and the common difference is 2, right? We don't know what the last term is because we didn't count all the way, but is there a sum formula that utilizes all these pieces? And indeed there is. It's this variation here, the second variation, that has that we have all the required pieces. We have the number of terms, n, we have the first term, a sub 1, and we have the common difference. So I don't need to know what the last number is. I can go ahead and apply this variation here. So knowing that s sub n is equal to, I'm just going to copy the formula again, n over 2 times a sub 1 plus n minus 1d, we have s sub 50, because that's how many numbers we want to add, is equal to 50 over 2 times 2 times 1 plus 50 minus 1 times 2. And then you just do math. Plug into your calculator or what have you, calculate it, compute it all, and you're going to get 2,500. So if you added up the first 50 numbers, your grand total will be 2,500. So it's pretty simple, pretty easy peasy, I hope. Let's do another example. Find the following partial sum: 3 plus 7 plus 11 plus 15 plus dot 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 plus 159. In this case, as before, they didn't tell us it's arithmetic, so we can't assume that, even though this is 12.2, arithmetic sequences and series. Let's just quickly confirm that this is arithmetic. So from a 3 to a 7, that's a plus 4, plus 4, plus 4. So although this is only the first 3 terms, we can feel confident that it is arithmetic. Now, what makes this question, quote, hard is know that with either variation of the sum formula, we need to know the number of terms. It is present in both formulas. And in this particular example, it does not give you the number of terms, right? And because of this dot, dot, dot here, we can't just count it up. How are we supposed to do this? Well, they do tell us that the very last number is 159. We just verified that it is arithmetic. So recall, since this is arithmetic, the formula, the specific term, is equal to a sub 1 plus m minus 1d is unlocked. So we can use that formula, because remember, this is a sub n, this is not s sub n. A sub n is for a specific number. We can use this formula with the last term to figure out, hey, what term position is he? Because since he's the last number, his term position should be the same thing as the total number of terms. So that's what we're going to do here. So we can just read that what a sub 1 is 3 and d is 4. Therefore, 159 is equal, because that's what I'm looking for, 159 is equal to a sub 1, 3, plus n minus 1, I don't know what n is, times 4. So that gives us an equation to solve for the number of terms. So 159 plus, or equals, 3 plus 4n minus 4. So bring everything over, so that's 160 equals 4n. So n equals 40. So all that math tells us that we have 40 terms. So once we have n, basically you can use either variation of the formula because we have all the pieces necessary. I'll go ahead and since this one looks smaller, I'll go ahead and use this variation here. So knowing that s sub n is equal to n over 2 a sub 1 plus a sub n, so we have s sub 40 is equal to 40 over 2 times the first number, which you said was 3, plus the last number, which you said was 159. Right, there we go. And then you just do math. So that's 20 times 162. 20 times 162 is, what, 3240? Right. So, easy peasy. So yeah, that's arithmetic series for you. You have two formulas, and you use whichever one you have enough information for. Let's just do one last example. Let's do a word problem. We haven't done a word problem in a while. So suppose an amphitheater has 50 rows of seats with 30 seats in the first row, 32 seats in the second row, 34 in the third, and so on. Find the total number of seats. So again, let's pretend that this is not 12.2 arithmetic series. We have to verify it's arithmetic before any of those formulas are unlocked. So since the question says find the total number of seats, it's asking us to add up the seats. And they did give us numbers, right? 30 seats, 32 seats, 34 seats. So we're adding 30 plus 32 plus 34 plus, and it said and so on. So dot, dot, dot. And hopefully with these three terms, we can verify that it is arithmetic because we have plus 2 plus 2. Now all of these are rows, and they did tell us that we have 50 rows. So it's not a guess. I know for a fact that we have 50 numbers here. So with all of this, hopefully we can see that the first term is 30. Since it's arithmetic, we have a common difference of 2. And they actually did tell us the number of numbers. 50. Hey, that is just enough information to use the second variation of the sum formula. Therefore, if s sub n equals n over 2 times 2a sub 1 plus n minus 1d, that's the formula, just plug everything in. S sub 50 equals 50 over 2 times 2 times 30 plus 50 minus 1 times 2. And then you just go ahead and, do math. So if you were to calculate it all, compute it all, you're going to get 3,950 seats. This amphitheater has those many seats. So hopefully this will be pretty simple and straightforward for everyone. Once you verify it's arithmetic, those formulas are unlocked, and that's all you need to answer these questions. Good luck.